Recording in progress.
Welcome back, everybody. This is going to be my final video for this semester. This is not on the final. It's just for your coding enjoyment and increase in knowledge. We might have hit separation at the end of CSCI 1, true separation, not just prototype and implementation. We're going to hit it in full today. And then we're going to look at namespaces and a couple more things that are kind of cool. So I copied this over from the namespaces thing, and I just copied them all into one file. So you'll see what happens here. So we've got using namespace std, that's our standard one. Then I've got one called a namespace called Jefe, where I have x is set as an integer that's constant at 15. And then I've got two functions, square me and cube me. And then we have another namespace called util for utility. It holds pi to 2 decimal places. It has x set at a different constant, and it's got a void print message. And so we're gonna just run it and see what it all says. Really? Is the file name too long? Yep, file name's too long. Damn it. All right. Well, let's try this again. CSCI 02, day 19, name file 23, namespaces and separation. All right, let's try this again. Yep, file name was too long. So we've got it cubing 36 and squaring it from, it's pulling from Jefe's square me and cube me functions. So, and then it's got 15 and 33. So we're able to have two different x's. They're just in different namespaces, which is kind of cool. And then the print message must be a line from Lion King. That was inspired by a conversation with Voldemort the other day. Put that in there. So what's going on? Why do this? Well, when you're working for a company or something like that, there's going to be a bunch of you working on the same project. And so maybe having namespaces that correspond to you would be helpful that way, because a lot of us are going to use x as variables and shit like that. And they can't all mean different things. I could make this a double over here. And now we've got x set as two different things, two different types too, which is kind of neat. So how would we use this on a project though? This is where separation comes in. So what happens is we are going to create a header file. And the header file is an option pre-built in Visual Studios if you use Visual Studios. It automatically comes on Visual Studios with Pragma once. If you're working with a different IDE, it may or may not add that in, so you're going to need to have it in there. Pragma once, what it really does is it says, if we're loading a bunch of these, don't reload the same libraries. If the library is already loaded, don't load it again. Load it once. And then that's not what I wanted. Let's get rid of that one. Let's rename it. That's what I wanted. I'm going to call it Jefe because that's the name of my namespace. And I'm going to make a resource file also. A resource file should be a C++ file. And we're going to call this Jefe. The names need to match letter by letter, capitalization by capitalization. And so what we're going to do is we're going to take, let's get my source file over here. Let me open up that. So I got all three in a row here. I'm going to take my stuff from Jefe. And I'm just going to put it over in Jefe header. So it looks like I don't need that. I already had it. Or Visual Studio loads it. And then I'm going to take anything that this has just got the name of the functions. So these are my prototypes in my namespaces. And then I'm going to put the implementations of my prototypes in my resource file. And to do that, I need to tell it where it's coming from. And we can put other stuff in here so we don't need it in the main one. But I am doing a C out. Let me undo that. I want to make it kind of clear. So I'm doing a C out and there's some errors here. And I'm doing NL. C out. And these things are not standard, so we got to access them. So including IO stream just allows us to print a screen. And STD, C out and end line are in the standard library. So I could have avoided doing that by doing STD, C out, and STD end line. And that's kind of why they do this. I hate when I go look shit up because it's harder to read. To me, it's harder to read. If I'm looking up code or something to speed up my work or get ideas from somebody else rather than copying, I like to do all my own code. But sometimes getting an idea, a catalyst from another source is good. By including the scope resolution and saying this is COUT's in the standard library and so is end line, it just makes it a little bit more verbose, and so Jefe could have his own COUT. In fact, let's give Jefe a COUT. I want to make sure everything's running here first. It doesn't like this yet until I tell it to include Jefe. We already have that stuff. So everything hopefully is working. Let's save all and then run it. And it is. So what I've done is I've taken all my stuff and it's in my own private files. I can update my private files as needed, and wherever it's used here, it's just referenced. So let's go make my own COUT. Oh, can I make my own COUT? That's a little more complicated. Printing to the screen is already, fuck. That's probably not the best example. Trying to mimic something from the standard library is a lot more. I don't know how to go to screen without using the IO stream. What else could we want in here? Well, we don't need my own. We could, let's say Joseph has his own. And we'll come over here and we'll make a Joseph header file. And we are going to create a Joseph resource file. And let's see, what has Joseph got in his stuff? We got some squaring functions. Let's see, what do we want to do? Maybe he'll have his own X. Can we make it non-constant? Let's find out. What kind of functions should we have? Let's see, my squaring functions are returning integers and taking in integers. Let's make Joseph have some taking a float. And we'll come over to Joseph. We need to tell it to include Joseph. There's it, quotes. Maybe quotes. It's quotes. The brackets are for the good shit. Quotation marks are for homemade shit. We need a space. We should have a space. Let's put a space there. Return. That's got taken an arg. Return arg times arg. And cube me's got to take in an arg. And it will return arg times arg times arg. Just include the IO stream. Just cuz. And Joseph likes to have namespace STD in here also. And so having it in the pragma once, what it's doing, if we go and include all these, like see Hefe's got it. No, not there. Hefe's got it here. Oh, Hefe. It's got it there. We got it in the IO stream. Oh, I didn't. I didn't. scope it. So they both have it, and we come over to the main source file. All these near each other. Come over to the main source file. It's scoped here. When we run this program, we got using namespace listed in a couple spaces, and we've got include IO stream here, and in both of these header files, pragma once prevents it from being loaded more than once. And so here we could do cout 6 squared. And we could do a Joseph square me. Equals Joseph cube me. And so now we have two different squaring functions, MFR. One or more multiply defined symbols was used. Let's try that. Yep, wanted it as a constant. So that kind of sucks, but we've got two different functions. Let's just say me and Joseph happened to come up with the same name for something. We both liked it, we used it, but neither of us knew what the other was doing. We could make it like this. Let's say Isaac Newton and Leibniz came up with derivatives at the same time, different parts of the world. Let's say they were working on a C++ project together, and they both made a derivative function, and they do the same thing. So one would have Newton and one would have Leibniz. So it allows people, that's an example of people working on the same thing in different places. As one of the first, that's just the first thing that popped in my head as an example. So this is kind of cool. Gives us like real separation. There's nothing here. There's no functions. There's just the main. Everything we need is in our resource files and header files. Header files just gives us some stuff to access, and our resources have our implementations of them. That's not bad, you know. Let's see. Okay, then another thing I wanted to show you was this one. So this was, what I've done is I've taken the two things from this page and the next page and kind of added them into one file and commented out part of it for now. I'm going to close that one. I don't need it anymore. So what has this one got? It's got the IO stream. It's got C math, so it's going to be doing some math. And the way we did structures, we got point structure. It's got an integer way of setting up the point. So we don't have, we're only using on the grid lines. There's no like fractional components, decimal components. Our standard constructor was point int argx equals 0. And then we have something introducing this. So what this does is it references itself. Okay. It's an awkward way of doing it, but sometimes it can be handy, as you'll see in a second. We've got a set Y. Interestingly enough, I have it set up to return it rather than just do a void. Normally we did void set, and then we would do when we did get, that's where we would have the return. There's a reason for this. I'm going to show you in a second why I've set it up like this. I got the idea. I want to say it was from Geeks for Geeks. It is one of the ones online I saw when I was looking up different uses for this. So when we're doing a display point, we can see how this references its own point or args point. Let's see. This is still all in structure. So display points is taking in a different point. Okay, we are in one single structure point. It's taking in a different point. And so it says, okay, the point we're at, the one point I am, like point A and point B. Point A is taking in point B. It says, okay, let's spit out where point A, X, and Y is. And then we're going to say where point B, X, and Y is. And then we can calculate, then they've got a method to return the distance between them. Must be where the C math comes in, square root and pow. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. x2 minus x1 squared plus y2 minus y1 squared. So it allows us to use two different y's, and like it's easier to reference the one coming in, but if this function's inside the point, then you need to have a way of referencing your own x. And just doing this can get confusing, like which x is it? So like this just makes it a little bit more verbose and stuff like that. We're going to look at the asteroid thing in a second. So we've got object set up to 5, 5. Object 2 is going to be a copy of it. Check this out. We have compound functions. This is like f of g of x from mathematics. Compound functions or chained functions. But really, what we're doing is when we do this one returns a point. So this is the point of doing this, setting up a point like this. If I set up x, when I change x, it returns a point, a reference to the point, so that I can set stuff up. So when I change object 1, this was 5, 5. I changed the first 5 to a 10, and it returns object 1. This part's done. Now it says object 1 set y20. And says, okay, let's go change object 1y. So it changes it to 1020. Which was really neat. And this is an example of it doing the distance between the other point. Object 2 is saying, what's the distance between 5, 5 and 1020? It's 15.8114 units. Now, you may be going, well, why can't we just set up another function out here that takes in 2 points? and kind of does the same thing. We just call it arg1x and arg2 or arg1y and then arg2x and arg2y. And we could. And that would very much work. But sometimes you just want to do it from the position of whatever you're working with. You're working with an object. You don't want to step outside the object and go, okay, let's do main thing. Maybe you're making a fucking game. And this isn't the distance from a point to another object, but it's the distance from your character to a target that you're trying to shoot out. And you got your bow and arrow or your gun, and it's got a ranged attack, and the range is only so far. And so you need to know how far away the bad guy is from you. And this calculates the distance without stepping outside of you and going, let's do, let's zoom out and calculate. No, you just does the distance from your perspective. So that's kind of like the point of using this stuff, where having you're referencing it within yourself, stuff like that. Let's see, what else do we have in here? So we have the asteroid class. So if you've played the game Asteroids, it's got like asteroids appear and they collide and they do stuff like that. And we have a new shit, what's the word here? I'm blanking on the name. Command or something like that. Let's go with command. Static int count. Static variables are shared by all, and let me rephrase that, all instances of this object. So if I've got 10 asteroids, they all access the same count. Okay. So how do we work with it? Well, we got this. The count, whenever we create a new asteroid, it looks like count. What it's doing is saying how many asteroids are out there. When you play the game of asteroids, the object is to break all the asteroids. You're shooting them. You got a little ship. The asteroids are flying around. They bounce off each other, and you don't want them to hit you, so you shoot them. You can spin in like 360 degrees, and you shoot at any angle. So you try to shoot at anything that comes near you, and when it hits it, it breaks the rock, and the rock splits in like a Y, so it doesn't hit you. And so count, this is keeping a track of all the asteroids in play at any given time. So whenever we create an asteroid, constructor call creates one, we increase the asteroid count, and it's known by everything. When an asteroid is destroyed, we destroy it. We take the count, lower the count by 1. At any time, we can reference the count. Okay. To initialize a static variable, you need to do it outside the thing, outside the class. This way, it's accessible by all objects of the class. If you only have it instantiated inside one, then it wouldn't really be static. So it's instantiated out here, it's built out here, and all the other ones reference this single object. Now, we have regular functions. This is just doing a static variable of it. We also have the option of doing a friend function. Friend functions. So what they do, notice we've got void print asteroid count here and void print asteroid count here. By saying friend, this is no longer a member function. What this does is this sets up friend functions, set up remote access. without using git commands. So I don't have to access any particular thing. What does void print count have in? It's just returning the count, which is right here. So it's not a specific asteroid that it's working on. It can work on any of them, but since the asteroid count is not in any specific asteroid itself, we can reference it anywhere, but this has access to other things in this class. So if you come over and look at the static variables and friend functions, we can actually do a friend class as well. And it allows, well, I got it written here. A friend class can access private and protected members of other classes in which is declared as a friend. It is sometimes useful to allow a particular class to access private and protected members of the page. And so they give an example of this, making class geek for geeks, and another class accesses it. I don't know how helpful it is, but you might find it helpful in whatever you're working on. So if you want to be able to share private, protected, and public members without using accessor methods, you can do this. Now, be careful because you're giving them access to your shit, which means they can change it. Okay, it's not just accessor methods. It's not just retrieval methods. They can change shit in there. So be careful with friend functions, but they have their uses. So we've got static variables where you can have them outside, and let's see. Let's just turn on this one right here. Let's turn on the asteroid bit. And I'm going to comment out those. And I didn't do any separation, put anything down below. I've got it up here so it was easy to see. So what's going on here with the code? It spawns a pointer to 3 asteroids. When we make the red asteroid at size, I think that's size. Is that size? Size. We make a red asteroid at size 10, a green asteroid at size 20, a blue asteroid at size 30. Each one increments the count by 1. So when we do print asteroid count, we're up to 3. When we destroy the asteroid, we delete it. So it drops down to 0. And then we can make a new asteroid. X pointer, we already have it created. So like deleting the pointer does not delete the pointer itself. You're just deallocating the memory to which it points to. Remember that when you delete a pointer, it doesn't get rid of the pointer. It deletes deallocates the memory that you're accessing. You still have the pointer, so you can still reassign it. That's what happened here. We assign it to purple. A purple asteroid is size 5, and now there's 1 asteroid on the field. So if you're doing this in a video game, you've got monsters, you're fighting fucking goblins with your bow and arrow, you got your ranged attack. We had our distance thing saying, you know, how far away is the goblin? You shoot the goblin. If it's close enough, you can hit it. If it's not close enough, you can't hit it. The game has it, so we keep track of the number of goblins in play. And as soon as you clear out like the goblin warren or goblin base, the level's cleared. And so you can keep track of how many goblins are left. Whether your character can see it or not, the system needs to know how many goblins are left so when the level's cleared. So that's something where use of this static variable. And that's it. We've done namespaces, we've done separation. So when you're working on projects, that's what you're going to want to do. So you can work with other people. And that way you have your own commands and stuff like that. Then we looked at static and friend count or friends, and then this. I really like, I really like, let me turn this back on. I really like the chain function call or compound functions. That's pretty neat. That's the point of doing this. Returning the point. Alternatively, we can set up, instead of having it like a point constructor call like this, we can have this. This does the same thing. So another use of the this, it allows you to access stuff inside of it. What is that red box right there? I don't like a 0.5. I've just been crazy. Still runs. That's it for today. That's it for the lecture. Peace out. It's been great. Stay in touch.